Our third discussion is about data types. So basically, as part of the objectives of this discussion, you should be able to understand the different data types that we are using in VHDL programming, differentiate between the difference of the single signals or the scalar signals and the vector signals, and recognize which data types are synthesizable and which are not. So this is very important because we needed to convert are designed to equivalent circuit to make it synthesizable. And of course, we needed to write our own data types. So these are the topics, different data types in HDL, predefined data type, user-defined data type, and application example with emphasis on the difference between a single bit and a bit vector. So let's now explain the bit and the bit underscore vector. So, pag sinabi natin na bit vector, so two-level logic po ito, either 0 or 1. Laging ganun po yung ginagamit natin for the bits. And then to declare the signals of this type, so we could use this one, signal x colon bit, in which x is declared as a one-digit signal of type bit. Yan, itong example na tong signal x na to, colon bit is a scalar example. And then we also have signal y, colon bit underscore vector 3 down to 0. So ito na po yung tinatawag natin na vector signals in which meron po tayong 4 bits with the leftmost bit being the most significant bit. Yung pinaka nasa leftmost po, yung pinaka most significant bit, and then yung least significant bit yung nasa rightmost. And then another example, signal W, colon bit underscore vector 0 to 7. So W is an 8-bit vector with the rightmost bit being the most significant bit. So there's a difference from this 3 down to 0 to 7 in such a way that yung Indian convention, nung 3 down to 0, this is little Indian convention, and then yung 0 to 7, big Indian convention. But we usually use 3 down to 0 as the little Indian convention example. So let's now proceed with the predefined data types. So we have different types of VHDL data types like the predefined, the user-defined, and the subtypes. Yan. So how are we going to assign values to those signals? So this first example, x less than equal 1. Ang ibig sabihin dito ng x, it is a single bit signal whose value is 1. Notice that the single quote is being used per single bit, just like what we did in the previous experiment, diba? So another example natin, y less than or equal to quotation 0111. So in which y is again a per bit signal, apat yan, 1, 2, 3, 4, whose value is 0111. And then we notice that we make use of double quotes. So remember that for scalar signal, we use single quote, and for vector signals, 2 or more bits, we use double quotes. Another example, so this is an example for 8-bit signal whose value is 01011011. Actually, the most significant bit here is 0 kasi siya yung nasa pinaka-leftmost part. But if we're getting the 2's complement of this expression, yung magiging most significant bit niya is 1. Kasi nga 'di ba, alam natin yung complements, we add 1. And then magki-carry over siya. Kaya magiging most significant bit niya this time is 1. So let's now proceed with the use of standard logic and the standard logic vector. Kanina we used bit and the bit logic vector. So in here, signal x colon standard logic, x is declared as a one-digit signal of type standard logic. And then kapag gagamit naman tayo ng vector, again, web signal y colon standard underscore logic underscore vector 3 down to 0 colon equal kung ano yung gusto nating i-assign na value for this standard logic vector 4 bits. So inassign natin sa kanya 0001. So again, y is declared as a 4-bit vector with the leftmost being the most significant bit, and the initial value that we set for this declaration is 0001. So notice that we use colon equal this one so that we could establish the initial value. So similar to our other programming languages, di ba? So kapag nag-initialize tayo ng value, yung nagamit natin doon equal. Pero this time, since VHDL tayo, we're using colon equal. So notice that most of the standard logic levels are for simulation only. 0, 1, and high impedance Z are synthesizable. So more predefined data types, of course, web Boolean, true or false lang naman yan, or 0 and 1. Then the integer, 32-bit integers. Yan, this is another example. We could set the value of n to less than or equal to 1,200 as integer, then another m less than or equal to 1 underscore 200. So again, this is integer example. If ready, then, so we could set the value of ready to be true. Yan, kasi 'di ba yung boolean natin either true or false lang. Example, so this time we assign x the value of 0. So again, this is a bit or standard logic example. Then we make use of x less than or equal to 0, 0, 0, 1, 1, 1, 1, 1 bit vector ito or standard logic vector kasi more than 2 bits. And then x less than or equal to b or the binary 101111 is simply a binary representation of the decimal 47. And then x less than or equal to x, malaking X, quotation 2f is basically the hexadecimal representation of decimal 47. So take note, b is for binary, x is for hexadecimal representation. Pero ang common naman na ginagamit natin is binary. User-defined data types. So, pwede rin pong enumerated. Say, for example, type, then bit is 0 and 1. Then type, my underscore logic is 0, 1, and then Z. Type state is pwedeng idle, forward, backward, stop. Or type color is pwedeng red, green, blue, and white, and so on. So, ini-enumerate lang natin yung mga possibilities of different types that we would like to use. So, another example for the integer. So, although hindi naman natin ito masyadong gagamitin, pero meron tayong ginagamit na type integer is range, type natural is range, type my underscore integer is range, type student underscore grade is range. So, you have to specify kung ano yung range na gagamitin natin for different variables that we are trying to use. So, we have two categories of user-defined data types. We have the integer and the enumerated. And here's an application example. So, single bit versus bit vector. Ito yung gagawin natin mamaya for the experimentation. So, we have the first code here. Napansin nyo, 1 bit lang yan, scalar lang. So, yung part natin A, B, then output X. So, pareho lang po silang in-bit, then out-bit. Then, architecture is still the same sa ginagamit natin, X non-blocking statement A and B. Yan. For the second example of code, dito manonotice natin gumamit na tayo ng in-bit vector 0 to 3. Ibig sabihin 4 bits yung gagamitin natin for inputs A and B. Then the output vector is 0 to 3. Ibig sabihin 4 bits din yung ating output variable X. Pero the architecture remains the same. So hindi man siya kailangan mag-change. The only difference here is 1 bit po yung input tsaka output dito sa code 1 and then 4 bits naman yung inputs and output dun sa ating code number 2. So this is the logic symbol for that. So for this is for the first code and will also apply to the second code. The only difference nga is dito instead na 1 bit, 1 bit, 1 bit, magiging 4 bits, 4 bits, 4 bits following our example.